So good morning friends. So this is my next lecture on the same topic, that is the solid state, and today we are going to discuss the new point from the solid state, that is the crystal structure one. Crystal structure one. Actually we know that in previous lecture we covered that is the types of solid, crystalline and amorphous solids one. Isn't it? If you consider any solid, if you consider any solid, then that solid consists from its constituent particle. That solid consists from its constituents particles one. And these constituent particles of solids, it may be atoms, isn't it, or it may be ions, or it may be molecules, or it may be molecules. म्हणजे सॉलिड्स जो असणार आहे त्या सॉलिडच्या क्रिस्टल स्ट्रक्चरमध्ये जे कन्स्टिट्यूंट पार्टिकल्स असतात ते ॲटम्स असणार आहेत, आयन्स असतील किंवा मॉलिक्युल्स असतील. सो देर आर ॲटम्स, आयन्स आर मॉलिक्युल्स आर प्रेझेंट ॲज अ कन्स्टिट्यूंट पार्टिकल्स इन एव्हरी सॉलिड्स. Now if you consider different solids, different solids, whether different solids have same crystal structure, different solids have same crystal structure, or they possesses different crystal structure only. Yes, different solids do not have same crystal structure, means we say that different solids have different crystal structure. Different solids have different crystal structure only. As different solids have different crystal structure, in the sense the arrangement of these constituent particles, maybe atoms, ions or molecules in that particular crystal is different one. And due to difference in the arrangement of these constituent particles one, it results in the formation of different solids one. We can say that it is a different crystal structure one, different crystal structure one. So before going to study that, what are the factors those are responsible for the different crystals, how originates one, isn't it? So before that we have to study exactly how crystal structure is formed, So before to study crystal structure, how it is formed one, so for the formation of crystal structure, the two basic components must be required, or two basic factor must be necessary one. That is the one is the lattice, and second one is the basis. So lattice and basis are the two what we call as a basic requirement for the formation of any crystal. One. So lattice means what? Yes, lattice means what? See, lattice, they are the three-dimensional imaginary set of points one. Okay, three-dimensional imaginary set of points one, which are repeated in a periodic pattern, or which are repeated in periodically manner, they are called as a lattice one. Just see here how lattice we can explain here, how lattice can be explained on. Suppose lattice means what? Suppose these are the points. Okay, suppose these are the points one, and if these points, if I going to repeat in three-dimensional, actually this whatever I am going to show here, it is in two-dimensional one, isn't it? Along x-axis and along y-axis one. If we what we call as along z-axis, if considered, means above the blackboard or below the blackboard one, if you extend the same dots one, these dots actually is three-dimensional. Just imagine above the blackboards also we place some points are there. Okay, points are there. Then three-dimensional imaginary set of points, it is a whole set of points one. Okay, which is repeated in periodically in the sense, if you consider the environment of any point, okay, if you consider this point one, then surrounding this point at particular distance, whatever set of points comes on, same environment is present for all these points. This point also, same environment is present all these points. Okay, all these points. So that's why it is said as a periodically repetition is there, isn't it? So this is set of points we call as a lattice one. This set of point is called as a lattice one, isn't it? Then basis means what? Yes, basis. Actually, basis is our constituent particles. Basis are our constituent particles are there. Basis is nothing but constituent particles, that may be atoms, that may be ions, or that may be molecules. Atoms, ions or molecules जे असणार आहेत. For example, if you consider atoms, ions or molecules, suppose Na plus is there. Okay, and Cl minus is there. These are the ions. These are the ions one. Okay, Na plus and Cl minus is there, isn't it? So actually this is the red set, whatever we are shown here, they are termed as lattice, and these Na plus and Cl minus ions are there. If atoms are there, then metals case मध्ये असणारे metals हे atoms असणार आहेत, सिल्वर असेल, गोल्ड असेल, प्लॅटिनम असेल, याचे जे atoms असणार आहेत, these are also considered as a constituent particles. These are considered molecular solids मध्ये येणारे molecules जे आहेत, these are constituent particles. So these are the bases. These are bases, also called as a motif. The bases are also called as motif असं पण म्हणतात. ठीक आहे. Now if we place the constituent particles Na plus or Cl minus on these lattice points, if we place these Na plus or Cl minus on these lattice points one, then there is a formation of crystal structure. There is a formation of crystal structure on this. If we place these lot of number of Na plus are there, and if I put in a ठराविक पॅटर्न मध्ये आपण प्लेस केले Cl मायनस, तर ह्या दोघांच्या कॉम्बिनेशन पासून तयार होणारे जे क्रिस्टल असणार आहे, दॅट इज द crystal structure of sodium chloride. That is the crystal structure of sodium chloride, which we will going to study after next lectures, isn't it? That is the crystal structure of NaCl is formed. Just basic requirement for the formation of any crystal structure is the lattice and bases are there. Lattice and bases. Lattice is the imaginary set of points one in three-dimensional in periodic sequence is there, and motif or basis are the constituent particles, maybe atoms, ions or molecules. Maybe atoms, ions or molecules. Remember well. And if you place these atoms, ions or molecules, okay, basis on the lattice point, it results in the formation of crystal structure. It is also called as an crystal space lattice. Also called as crystal structure. Also called as space lattice. So same can be explained if you consider the construction, बिल्डिंगचे कन्स्ट्रक्शन्स वगैरे असतात, त्यावेळेला सिव्हिल इंजिनियर जो असतो, तो सिव्हिल इंजिनियर काय करतो, पहिल्यांदा ब्लूप्रिंट काढतो. जस्ट ब्लूप्रिंट, ओनर जो असतो त्या ओनरला दाखवण्यासाठी ब्लूप्रिंट काढतो की तुमचं मेन हॉल इथं असणार आहे, बेडरूम, किचन, इजंट इट, अशा प्रकारे फर्स्ट फ्लोअर, सेकंड फ्लोअर, हे सगळं ब्लूप्रिंट पेपरवरती रिप्रेझेंट केलेलं असतो. पण ब्लूप्रिंट जी आहे इट इज नथिंग बट लॅटिस. ती जी ब्लूप्रिंट असणार इट इज द लॅटिस. आणि त्या ब्लूप्रिंटवरती ज्यावेळेला कन्स्ट्रक्शन तयार होईल, म्हणजेच आपण ज्यावेळेला त्याच्यावरती व्हॉट वी कॉल ॲज कॉन्क्रीट किंवा जे आपण ब्लॉक्स असतात ते आपण ठेवू, म्हणजेच बेसिस ज्यावेळेला ठेवू, त्यावेळेला रिझल्ट्स इन द फॉर्मेशन ऑफ क्रिस्टल स्ट्रक्चर, रिझल्ट्स इन द फॉर्मेशन ऑफ दॅट कम्प्लीट जे हाऊस किंवा होम असणार आहे, ओके, त्याचं काम कम्प्लीट होणार आहे. मीन्स दॅट इज द कन्स्ट्रक्शन इज कम्प्लिटेड. सो लॅटिस जे आहे ते ब्लूप्रिंटचं काम करणार, आणि त्या ब्लूप्रिंटवरती आपण त्या ब्लूप्रिंटप्रमाणे जर कन्स्ट्रक्शन केलं तर तयार रिझल्ट काय येणार तुम्हाला, complete construction of that house, isn't it? Okay, so this is the lattice and basis one. Now next point, that is very important one, that is the unit cell. Means what? See, unit cell. Now see here, unit cell. Now as far as unit cell is concerned, unit cell is the smallest repeating unit, smallest repeating structural unit, smallest repeating structural unit, which when repeated in three-dimensional results in the formation of whole crystal. So smallest repeating structural unit असणार आहे क्रिस्टलचं, त्या स्मॉलेस्ट रिपीटिंग युनिट जे असणार आहे क्रिस्टलचं, त्या स्मॉलेस्ट रिपीटिंग युनिट ऑफ क्रिस्टलला काय म्हणणार आपण, युनिट सेल. वी कॉल एज अ युनिट सेल वन. सो when this unit cell is repeated in three-dimensional, it results in the formation of whole crystal structure. One. So this crystal structure is formed, isn't it? Now if you consider unit cell, okay, one, I will try to draw here unit cell one. Suppose simple unit cell, that is a cubic unit cell. Like this, suppose it is unit cell, simple cubic unit cell is there, isn't it? And if suppose this unit cell, if I going to place, or if I place such number of unit cells surrounding this particular unit cell, means to the left side, right side, above this unit cell, below the unit cell, in front of the unit cell, back side of the board, okay, in three-dimensional, if we expand them, then it results in the formation of whole crystal structure 1. It results in the formation of whole crystal structure 1. It results in the formation of whole crystal structure 1. That can be also, I would like to show here. Now see here, just consider, if we consider whatever is the top surface of the crystal, it is the side surface of this crystal unit cell, it is front face of this crystal, and this one is the side, okay, face of the crystal. So whatever in red, what we call as lines, whatever I shown here, crystal unit cell, if this unit cell consider on the same picture is there, this is unit cell from this crystal, ह्या क्रिस्टल मधून हा एक युनिट सेल आपण जर सेपरेट काढला तर इट रिझल्ट्स इन द फॉर्मेशन, दिस वन इज द युनिट सेल and this is the whole crystal structure, one. So from this whole crystal structure, if I remove the one unit cell one, the same what we call as nature or the structure of the unit cell is same as that of the whole complete crystal structure one, and all the properties of the unit cell and whole crystal structures are same, okay, whole structures are same one. So this is the what we call as a unit cell. The unit cell is the smallest repeating structural unit of crystalline solids one, which when repeated in 3-dimensional results in the formation of crystal structure one. That can be shown here also. If you consider this Rubik's cube is there one, okay, and if you consider the, suppose Rubik's cube is there, suppose it is this crystal structure is there, and if I remove one what we call as a unit cell, if I remove the one unit cell from this cube whole crystal structure one, then this is the unit cell, and this one is the crystal structure, If we separate all such what we call as the unit cells blocks from this Rubik's one, and if we arrange, okay, again, then it results in the formation of whole crystal, one. See the shape of this poor complete what we call as a crystal structure, and this one is the simple unit cell one. Okay, just it is small in nature, it is macroscopic, means when we arrange the unit cell in 3-dimensional results the formation of crystal structure, So again different solids have different solids possesses different crystal structure, okay, but the basic point is that actually different solids have different unit cell one. Different solids have different unit cell. जी unit cell असणार आहे, unit cell मध्ये difference असतो, आणि त्या unit cell मध्ये difference जो असणार आहे, unit cell मध्ये difference मुळे results the formation of different crystal structure one. Now how that can be explained here. See here, if you consider the crystal structure, just see, this one is the unit cell, simple unit cell, cubic unit cell is there, isn't it? Now if the cubic unit cell is concerned, then there is a difference, means with respect to that is edge length. Suppose this one is the A, okay, suppose you call it like this one, A, B and C, these are the edge lengths, this one is the A, B and C, isn't it? And if you consider the angles between C and B, suppose this is the alpha, between C and B, suppose it is alpha, isn't it? Then yes, between A and B, suppose beta, then C and B covered, A and B covered. So between, yes, between C and A, between C, this edge and this edge are symmetrical. This one is the A. So between A and C, suppose it is gamma. So between A and C, it is gamma. So alpha, beta and gamma. If you consider alpha, beta and gamma जर consider केला तुम्ही C आणि A, ठीक आहे. अल्फा बीटा गॅमा जर कन्सिडर केला, सो द एज लेंथ जे असणार आहेत, दिस वन ए बी अँड सी, ह्या एज लेंथमध्ये डिफरन्स केला किंवा अल्फा बीटा गॅमा ह्यांच्या अँगल्समध्ये जर डिफरन्स झाला, ॲक्च्युली सिम्पल क्युबिक जर असेल, सिम्पल क्युबिक युनिट सेल जे आहे, ह्या सिम्पल क्युबिक युनिट सेलला ए इज इक्वल टू बी इज इक्वल टू सी अँड अल्फा इज इक्वल टू बीटा इज इक्वल टू गॅमा इज इक्वल टू 90 डिग्री. दीज आर द पॅरामीटर्स of edge length and edge angles for simple cubic crystal. And simple cubic unit cell is there, but there are number of what we call as unit cells are there. Number of unit cells are there one, and in that unit cells one, different what we call as unit cells one, the edge length and what we call as edge angles are different one. From crystal structure to structure is there. Cubic is there, tetragonal is there, rhombohedral is there, orthorhombic is there, triclinic is there, hexagonal is there, monoclinic is there. So which we'll study going to in next lecture one. Okay, it is the next part. It is the next part one, isn't it? Now, first if you consider the simple cubic crystal one, then or in that crystal structure, that is the, if you consider the possible arrangement, what am I saying? Possible arrangement of edge lengths A, B, C, okay, and alpha, beta, gamma, alpha edge angles one, there are only 7 crystal structures are there. 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 7 crystal structures असणार आहेत. And each crystal structure मध्ये difference in the unit cell केल्यामुळं त्यांच्यामध्ये जी अरेंजमेंट असणार आहे, that is the in 7 crystal structure there is a 14 Bravais lattices there. 14 Bravais lattices there means, in short we say that one, a French mathematician Bravais हा जो सायंटिस्ट आहे, ह्यानं काय केलं, जर सेम सेट ऑफ ॲटम्स असतील किंवा कन्स्टिट्यूएंट पार्टिकल्स असतील, ह्यांचे 3 डायमेन्शनलमध्ये अरेंजमेंट करून 14 टाइप्स ऑफ क्रिस्टल स्ट्रक्चर किंवा 14 टाइप्स ऑफ व्हॉट वी कॉल ॲज अरेंजमेंट पॉसिबल आहेत असं त्यांनी दाखवलं. आणि हे 14 टाइप्स ऑफ क्रिस्टल स्ट्रक्चर जे आहेत, दीज आर कॉल्ड ॲज अन Bravais lattices. They are called in Bravais lattices one. And these 14 Bravais lattices are categorized in 7 types of crystal structure. These 14 Bravais lattices are categorized, are considered or accommodated in 7 different crystal structures. 7 crystal structures. These are the cubic, rhombohedral, orthorhombic, monoclinic, triclinic, hexagonal, and it is the one more, that is the tetragonal. So all these 7 crystal structures, 14 Bravais lattices are there. And in next lecture we are going to study the how simple cubic crystal is there one. Actually what are the possible what we call as the types in that simple cubic structure मध्ये. Simple cubic आहे, body centered आहे, face centered आहे, isn't it? In each cases one, in tetragonal what are the possibilities, in orthorhombic actually all possibilities are there. It may be simple, body centered, face centered, end centered, like this one, isn't it? Which we are going to study in next lecture. Hope you understand all these things. Okay, good day.